Some of you may remember last year we looked at problems with swimming in currents when we did our trig unit. So now we're going to take this and connect it into vectors. So in still water, Jacques swims at 1.5 meters per second. So he's at a point A on the edge of the canal and wants to swim directly across it. But there's a current flowing in this direction at 0.5 meter per second. So if Jacques tried to swim straight across, he would end up getting pushed by the current. So the question is, if he tried to swim straight forward, what would his actual speed and direction be? So if we think about this, we would have our resultant vector is going to be Jacques swimming 1.5 at his speed of 1.5 meters per second. And the current is going to push him 0.5 meter per second. So his resulting vector is going to be this way. He's going to end up swimming towards the right. So we can find this resultant using Pythagorean theorem. So we're going to have root 1.5 squared plus 0.5 squared. I've already got the answers in front of me, so I can tell you that that's going to be the same as root 2.5, which is approximately 1.58 meters per second. So he's going to get faster, or he's going to appear to be going faster. And his resultant vector is going to be, or his direction, I can find this theta using tan. So theta is going to be equal to tan inverse of 1/2 over 1.5, or tan inverse of 1/3. That's going to be approximately 18.4 degrees. So he's swimming at this speed 18.4 degrees to the right instead of straight ahead. So he'll be going 18.4 degrees to the right of where he thinks he's going. So if he wants to actually end up at B, he needs to point himself towards the left. So we want to know what angle that should be and what will his actual speed be. So now we're going to think about sending Jacques off in this direction at his speed of 1.5 meters per second. The current's going to pull him back at 0.5 meter per second. And we're hoping to end up at point B. So now we want to think about what angle he needs to go at. So in this case, we can use sine. And get that our angle should be approximately 19.5 degrees. And then his resulting speed I can find with Pythagorean theorem. So his resulting speed, which I should use magnitude for, is going to be 1.5 squared minus the 0.5 squared. That's going to be root 2, which will be approximately 1.41 meters per second.